Okay, see, students, almost all theory is over. Now, remaining questions from exercise. See, exercise 2.9. What is first case? You are given a parallel plate capacitor having air as medium, having cross-sectional area A, 6 into 10 raised to minus 3 meter square, separated by distance 3 millimeter, charge 200 watt. First question is, what is capacitance? You know what is capacitance? C0. Why? It is C0 because medium is air. Okay. You know what is the equation of C0? C0 is equal to epsilon 0 A upon D. C0 is equal to epsilon 0 A upon D. You know each and every value. What is epsilon 0? A and D. Yes, you have to convert this D, that is 3 mm in meter. So first question over. What is C0? Epsilon 0 A upon D. Second is, what is charge stored on this capacitor? Let it is Q0. Let it is Q0. Okay. Then how to find this Q0? Q0 is equal to C0 into V. Q0 is equal to C0 into V. So it is easy question. Now what is change in case 2? See, initially medium between two plates is air. So capacitance, initial capacitance, initial charge. And what is initial potential drop? V0 is equal to 100 volt. Okay, when medium is air. Now what is question? See, if the medium between two plates, that is air, is replaced by mica sheet of dielectric constant K is equal to 6. Okay, so what is first change? This air is replaced by mica sheet of dielectric constant K is equal to 6. So yes, capacitance will be changed. But again you are given two cases. First, while the voltage supply remaining constant, it means, see, it is capacitor. This battery remains connected, but this medium between two plates is changed. This medium between two plates is changed. Clear? Initially medium between two plates is air. Now medium between two plates is mica sheet of dielectric constant K is equal to 6. Now see, as voltage supply remaining connected, in this case voltage remains same. Voltage remains same. Okay, so therefore V is equal to V0 is equal to 100 volt. Okay. Now we know that when air is replaced by another dielectric medium, capacitance changes. So what is new capacitance? New capacitance. That new capacitance C is equal to, it is C0K. It is C0K. What is C0? That you have to find. Okay. And what is K? Is equal to 6. So clear? So remember, when voltage supply is connected, remains connected, voltage remains same. V is equal to V0, 100 volt. Yes, capacitance changes. And now what about charge? So yes, you can find charge from this data. Okay, now what is charge on capacitor? What is charge on capacitor? Then Q is equal to, it is C. This C and this V. Clear? So what you have to remember? Voltage supply remains connected, V is same. Medium is changed, capacitance will be changed. Capacitance change, charge will be same. Clear? Now, B question. After the supply was disconnected, means this battery disconnected. Hello, students, like this. If supply was disconnected, battery disconnected, and the mica sheet is inserted, we know that charge on capacitor is charge on two plates, and that charge is stored from battery. So if battery is connected, how charges will induced on any plate? No, that charge will remain same. So if initially on these two plates charge is Q0, when battery is disconnected, charge on two plates will remain same. Charge on two plates will remain same. Okay, so now what is charge on plate? Charge on plate, Q is equal to Q0. Q is equal to Q0. Yes, medium is changed, so capacitance is changed. Okay, what is new capacitance? New capacitance C is equal to, it is C0. Okay, what is value of C0? You have. What is value of K? You know. Okay, now how to find potential? Yes, you can find potential. Okay, what is new potential difference V? V is equal to, C is equal to Q upon V, then V is equal to, it is Q upon C. Yes, you can also find this potential with the help of another equation, or V is equal to, it is V0 upon K. V is equal to, it is V0 upon K. Clear? So it is difference between two cases. While voltage supply remains connected, while it is disconnected, then what are changes? Okay, pause your video and write down from here. Okay, see students, exercise question number 2.29. You are given two spherical conductors of radius R1 and radius R2. Okay. Yes, there are two conductors and medium between them is air. Medium between them is air. As they are conductor separated by insulator, we know that it will form one capacitor. It will form one capacitor. Okay, when two conductors are separated by insulator, it will form capacitor. So yes, it is spherical conductor. Okay, yes, let this inner sphere on outer surface of inner sphere, there is negative charge. And for this outer shell, inner side, it is positive charge. So first of all, we will write it. See, let radius of inner sphere is R1, radius of outer sphere means outer shell is R2. Okay, that is shell. It is R1 and R2. Now, we are assuming charges. Let charge on outer, let charge on outer surface of shell of radius R1 is minus Q. Here it is minus Q charge. And similarly, charge on inner surface of shell of radius R2 is plus Q. Is plus Q. I shown in figure. Here it is minus Q charge and here it is plus Q charge. Okay. Now, if I am taking one point inside this small cell, inside the small cell, first case, okay, inside small shell, okay, means if I am taking R less than R1, and if you apply Gauss law, or if you know electrostatics of conductor, okay, inside this conductor, electric field will be 0. Inside shell, what is conductor? What is electric field? 0. Inside conductor, what is electric field? 0. Inside conductor, what is electric field? 0. So if I am taking any point, in this region, then electric field is equal to 0. Clear? Okay. Now, second. Outside of these two sides, outside means this point, at each and every point. Okay, outside means when R is greater than R2, then again electric field is 0. Now you may ask, sir, why 0? Because see, outside means if I am taking 1000 surface passing from these points, what is total charge of these two capacitors? Total charge is 0. What is total charge? It is plus Q, it is minus Q. Then what is total charge? Total charge is 0. Total charge is 0. Yes, total charge is 0. Okay. So if total charge on these two shells is 0, then for outside at each and every point, electric field will be 0. Electric field will be 0. Okay, so now electric field is only region between two plates. Electric field is only in region between two plates. Okay, electric field between two shells. Electric field between two shells. Okay, what is electric field between two shells? See, we will use this equation. Integration E dot ds is equal to sigma q upon epsilon 0. Okay, integration E dot ds is equal to sigma q upon epsilon 0. Now see, here it is. Integration E dot ds is equal to sigma q upon epsilon 0. I am taking electric field between two shells, means suppose this point, for this point, at distance r. So if you draw one Gaussian surface of radius r, one Gaussian surface of radius r. Okay, so for this Gaussian surface, we will find flux with the help of these two equations. Okay, first of all, see, electric field, as it is negative charge, and yes, we know that electric field is from positive to negative. Means electric field is in this direction. Any doubt? Okay, electric field is in this direction, inside. Okay, it is direction of electric field. Area vector ds. Area vector is always perpendicular outside, means area vector is in this direction. So E and ds, they both are in opposite direction. So how to write? It is E ds, or what is area of this spherical surface? We can write area of this spherical surface is 4 pi r square. Then yes, it is 4 pi r square. And what is angle between them? Cos 180 degree is equal to sigma q. What is charge enclosed by this Gaussian surface? It is negative charge. It is minus q upon epsilon. Okay, cos it is minus 1. So E 4 pi r square minus 1, it is minus q upon epsilon 0. So what is electric field? E is equal to 1 upon 4 pi epsilon 0 q upon r square. It is equation of electric field between these two conductors. Now how to find potential difference between two shells? See, potential difference between two shells, V is now potential difference between two shells, V is equal to minus R1 to R2 E dot dr. We know this equation. Okay, potential difference V is equal to R1 to R2 minus E dot dr. Now is equal to minus R1 to R2 E dr. What is angle between E and dr? See carefully here. Electric field is from positive side to negative side in this direction. And R1 to R2 dr, it means we have to bring unit positive charge from R1 to R2, means in this direction. So E and dr, they both are in opposite direction. So angle is 180. Okay, we know what is value of cos 180. It is minus 1. So minus will become positive. So it is integration R1 to R2. Put value of E. What is E? It is 1 upon 4 pi epsilon 0 r square q, and here it is dr. Okay, now q upon 4 pi epsilon 0 constant, so out of integration, so V is equal to q upon 4 pi epsilon 0 integration R1 to R2 1 upon r square dr. Okay, now you know what is integration of 1 upon r square. You already know it. Okay, it is minus 1 upon r. Limit is from r1 to r. Now put limit q upon 4 pi epsilon 0 minus 1 upon r2 minus 1 upon r1. So is equal to q upon 4 pi epsilon 0. Here it is 1 upon r1 minus 1 upon r2. 1 upon r1 minus 1 upon r2. So it is equation of potential difference. Now we have to find capacitance. See how to find. V is equal to Q upon 4 pi epsilon 0. If I simplify this term, it is R2 minus R1 upon R1. We know that capacitance is equal to Q upon V. Then from this, make Q upon V the subject. Q upon V is equal to 4 pi epsilon 0. R1, R2 upon, here it is R2 minus R1. Q upon V is called capacitance. So C is equal to 4 pi epsilon 0 R1 R2 upon R2 minus R1. This equation you have to remember. Okay.